quick, and we're going to finish this section and today as well. So, all right, so probability distribution, still talking about probability, but in a different way. Okay? So, probability distribution function, probability for discrete random variables. So, discrete, we talked about discrete in the past. So, we have discrete numbers, and we also have something else. Continuous, excellent. All right, we have those two types of numbers in terms of our number data, right? Our quantitative data. Quantitative discrete, quantitative continuous, right? Those two systems set up different systems for us to be able to talk about the probability of outcomes, right? So this chapter is about the discrete systems. So how do we deal with discrete systems? Or discrete is, again, is when we jump, right? Typically when we jump, now it's just going to be 0, 1, 2, 3, 4. Those numbers, those nice numbers we like, kind of thing. Whereas when we get to the continuous system, which will be chapter 6, that's our next chapter, we'll be talking about normal distributions. The normal distributions are that bell-shaped curve I've been drawing in the past, kind of thing. So I don't have anything, right? I have multiple things. I have infinitely many numbers between 0 and 1, technically, is what continuous means. So I can't really think of that next number. To be able to write that next possibility, that next outcome, I can't go there. I have to be able to draw it out. I have to be able to think in terms of a picture for continuous stuff. All right? So all that said in mind, I don't really need to worry about whether we're talking about discrete or continuous. Right? We'll be in that section. You'll know we'll be in that section. All right? So we're talking about probability distributions. That word should mean something to us as well. Distributions, we think of that bell-shaped curve sometimes when we're talking about continuous. For discrete stuff, we think about a frequency table or a bar graph. Here is a frequency table. We have talked about these, right? We've talked about these tables, right? So I am just labeling it a little differently. I am labeling X as my outcomes here. This is the outcomes I can get in this case. I forget what case it is. So a child psychologist is interested in the number of times a newborn baby's crying wakes its mother after midnight. For a random sample of 50 mothers, the following information was obtained. Let X equal the number of times per week a newborn baby crying wakes its mother after midnight. For this example, our outcomes are 0, 1, 2, 3, 4, and 5. That's in a week. I know that's not realistic because that could be in a night. For people and their mothers, you know this, right? So should go up to like infinite. So besides that, right? So these are my possible outcomes, right? I can't get anything between 0 and 1. Your baby's not going to wake you up happy, right? So 0, 1, 2, 3, 4, 5. It could go on a little bit longer too, depending upon what kind of data we get. And probability. So really what this is it's a frequency chart with my outcomes listed in this first column like we would do with any other frequency chart we had before. Right? Typically we would label this as maybe the number of times baby wakes a mother or something like that. But over here we don't have the frequency. Right? We have the relative frequency. That's what we have. We have the probability of that thing occurring. So we're no longer listing the frequency rate, which is just the number of times it occurred in our data. Right. We're listing out of the relative frequency. So let me write that down. That this is equal to the relative frequency that we have talked about in the past. That way you can make that connection, the relative freq. But we got rid of the regular freq. All right. So moving on, right? So this is this. So here's our probabilities that we have of those certain outcomes, and we can ask certain questions about this, right? And let me just say, so this notation typically doesn't go in here. We don't typically write that notation. We typically just write the probabilities, yeah, just the fraction or the decimal or even the percent. So yeah, you can just cross it out if you want, but we're just displaying what this is, right? This is the probability that a randomly chosen mother, right, is woken up 0 times in that week. This is the probability that a randomly chosen mother is woken up 1 time in that week, 2 times in that week, 3 times in that week, 4 times, 5 times, right? Those are those probabilities that we're trying to just kind of explain to you what they mean. But we don't typically write that in there because it's too much. Don't need to. I got the probability up here. I got that notation up there. So, all right, 2 things happen when we're talking about probability distributions that we need to point out for future information as well as for now. Is that things that make up a probability distribution is that first thing is that this has to be a probability, a real probability. Okay? So each probability, so that number 1 up there, each probability is between 0 and 1. It's got to be a number. It's got to be an actual probability. That doesn't make sense. Right? Baby can't wake me up -2% of the time.
Right.
What does that mean? Puts me to sleep? I don't know what that means. So, right, and a baby can't wake me up 110% of the time. Right? It doesn't make sense either. So, maybe in your mind it could, I guess. Maybe you're there. So, all right. So do we get that idea? So each probability is between 0 and 1, just kind of saying these are actual probabilities. They make sense, kind of thing. The sum of the probabilities is 1, meaning that if I add all these together, I'm going to get 50 out of 50, right? Which is 1. So total equals 50 out of 50, I think. I don't know. I didn't actually add it. So 13, 23, that's 36. Yeah, 50? I'll trust you. Which is 1. All right? So that's all that second one is. So if I asked you, right, determine if this is a probability distribution, you're just checking those 2 things. You're checking, I'm not giving you any negative numbers in here. I'm not giving you any numbers that are above 1, kind of thing. And then you total those things. And if you get 1, you got your probability distribution.
I'm a little bit confused. How do you solve it? 2 over 50?
That's just given to us.
Oh, okay.
So that's the information that's given to us.
Okay.
So now with the dollar,
Yeah, so you just add 2, 11, 20, 30, 21, and you should get 50 out of 50. So it's just a question of, do we actually have a real? Yeah. Feels nice, right? Compared to the last stuff?
That's good.
Easy question. So are the other ones as well. All right, so this is a distribution. Sometimes we look at this distribution to kind of glean some information. Most mothers are being woken up 2 times out of the week in this case. So according to our data. All right. Any questions about what a probability distribution? We're going to be using it, so let's make sure we get it. So, so let's do another question. Suppose Nancy has classes 3 days a week. She attends the classes 3 days a week at 80% of the time. So 2 days a week, 15% of the time. So she's missing some class, right? 1 class, kind of thing. 1 day, kind of thing, 15% of the time. 1 day a week, so she misses 2 class, 4% of the time. 2 days, I should say, out of the week. 4% of the time. And then 1% of the time, she can't make it during that week. Kind of. So let X equal the number of days Nancy, so I'm labeling my variable here. X equals the number of, oh, sorry, I'm really low. Just realized it. Yeah, that's the question.
Attends class per week.
Attends, yeah. Attends class per week. Attends class per week. We're just labeling the variable, making sure we understand what X is, and it changes. Right? And then we can think about what variables, what values X takes on. So if Nancy, this is the number of days Nancy attends class per week, what's my first?
0.
Yeah, so 0, she could attend 0 days, she could attend 1, 2, 3, 4, 5, 6, 7, wait.
7.
What? He does only 5.
I'm not writing those down. Why am I not writing those
I
down?
don't know.
Good question.
Oh, because you
Yeah.
wanna know, 3, yeah, okay.
She only attends class 3
Right,
days a
so we're
week,
done.
so she can
We've already
only
been given
attend
that.
class up to 3 days.
Yeah, we've only been.
She
given
can't go
already
7
given
days a
that.
week. So these are our only possible outcomes. So we're just trying to place the outcomes out there to say if we got a probability distribution, I can then write the probability distribution. So I think that's the next step, right? Suppose 1 week is randomly chosen, construct a probability distribution table, call the PDF table, like the one in example 1. The table should have 2 columns labeled X and P of X. What does the P of X column sum to? So let's do it up here,
Right.
because I have some room up here. I want to make a little table just like the one next to it.
So,
We have 2 columns. My first column is my
X,
X. My second column is my
P of X.
X. Oops. What? What's wrong with that? Nothing. I probably need to move that up. Yeah. There we're down. I mean, there we go. Got my directions good. So we got my 2 columns, right? My outcomes and my probability of getting that outcome.
Alrighty.
So I'm gonna my possible outcomes starting at
0.
0. Right, and we typically, that's one of the distributions, and we're going to do this for 3 sections. That 0 is one of the easy ones to forget about, and it typically does happen as one of the outcomes. Okay. So 1, 2, or 3.
3.
And then we're just asked to list essentially the probabilities of these outcomes. So what's my probability that she attends 0 classes that week? 1 out of what? 1 out of 100. We can use the fraction. We can even use the percentage. It doesn't matter. They give us the percentage. Why change it? Right? Remember, right? These frequency tables could be fraction, could be a decimal, could be percent. You can put anything there. Why make it harder on yourself and change it to something you don't need? So 1%. What's the probability of getting 1? Randomly choosing a week and getting 1. She only attends 1 time. 0.04, or since we have 4%, let's leave it as 4%. How about 2 days a week? And then last 3 days a week, she attends 80% of the time the full week. So there's my probability distribution. If I add those together, what do I get? 100%. That should happen, right? If I total them, I should get 100% or 1 if it's decimals. Last part was asked. Just in the information. It's just given to us, right? 3 days a week. She attends classes 3 days a week, 80% of the time. 2 days a week, 15% of the time. 3 days a week, 4%. Just listed in that information. So we're just writing it out. I'm just trying to understand if we get, right, how to do this on the table here. And then at that point, maybe we ask some questions about it.
And then we always have to put the sum of the probabilities of the bottom line.
Not necessarily. It's just, that's part of the probability distribution. That's kind of a check. I would do it, right? If I was on a test, I would make sure that that adds up to 100%.
Just to double check it.
Kind of thing, just to double check, yeah. Okay?
What if it doesn't?
If I'm giving you the information, right, and it doesn't come up to me because I messed up, kind of thing. So if it was like 79 and it only added up to 99%, we're like, what the heck, Andre? So you come up to me and you tell me. If it doesn't, and I gave you like a blank, so I think some of your homework has that kind of thing where it gives you a probability distribution, but it kind of leaves some blank, and you have to find it, kind of thing, using that 100% or that one kind of totaling thing. Okay, so, right. Flip